All right, everyone, I'm back, and now we're going to look at the bridge reader a little bit. So we've covered the bridge transformer and the bridge filter. The last step when we look at a bridge is the bridge reader. So let's open it up here. Similar to the bridge transformer, and I'll zoom in here on the left panel, left pane so we can see the files. We can see there's a package.json, and this contains all of the things related to the bridge reader. So we can see that main is src/index.js. We've got a script for starting, and we have some dependencies, again, node-mon and standard in development. And we do have some other things for actually spinning up a little server that is read-only against that MongoDB instance. So we're going to need express, cores, .env, body parser, EJS, and of course MongoDB to read data from the database. Now, I am just copying for the default bridge reader very similarly to what exists inside of the old Planaria code. Planarium to be specific for the read side. And what we have here in README.md is a file that describes our protocol. Now, I've written over here a very high-level description, if you will, of our protocol. But I want to put this into the README.md. So that's one of the things I'm going to do. Update the documentation of the bridge reader. So that way when we go to the bridge reader associated with our bridge, for example, if I go to bridgeport.babbage.systems and I click into the Hello World protocol, we can see, as I did before, that this is the documentation for that. It's right on the homepage of the bridge reader, and that comes from this .md file right here. So I would first, change this to say ties. What is this thing called again? I always forget what this thing is called. Postboard Protocol. And then we give a short description of the protocol, yada yada, and this protocol is actually going to be a little bit more complex than the Hello World protocol, but I'm going to update that later. I don't think I have to update that live while I'm recording, just in the interest of saving some time. So you can see the updated version of this .md file. Basically what you want to do is you want to model, when you're doing yours, model it off of this, right? Like you've got your protocol namespace. I'll change that much, right? I'll go here and I'll grab my protocol namespace and I'll copy it. And I'll say that way we have this, right? We have the sender ID. So field 3, sender ID, which is a base 58 encoded BSV address whose private key signed at least one of the inputs of the transaction. That's exactly the same. And then 4 would be, instead of the message, it would be the action to take. See below, right? And then you get the idea, right? So then I just write out I would say, send message, right? I would say set name. And, I'm just scaffolding this out so you can get an idea. When field 4 is send MSG, then ... right? And same with this guy down here. So you get the idea. When field 4 is set name, then ... And what does field 5 mean in any of those cases? And we already know what field 5 means in any of those cases because we already wrote the code. So I'll update this more later. What we have here is some views. These are EJS views. These I wouldn't say you have to mess with. You can if you want to get some custom behavior or fix some of the things that are kind of janky inside the old Planaria stuff, but I don't really think you have to mess around with that too much. The public, same deal. I mean, there's just some stuff there that is useful. This is all literally from the Planaria code. I didn't write that. Defaults is really the only thing, believe it or not, in the default bridge reader that you would need to change. These are setting the default queries and the default sockets for when you connect. So if I go to the Hello World Protocol query, right? The default query up here, collection hello, find, project message 1, right? Limit 10. That is specific to Hello World Protocol. So we would want to change this. And I'm actually going to say the names collection. I want to see the name of the last 10. Hang on here. I want to see the name of the last 10 people who were receiving, who have set their name on this protocol. And the socket, I'm just going to leave how it is. And that's it. Now we have our socket worked through, and we have our default query and our default socket set up. Now, if we look at this, what is this actually doing? I'll review the code briefly. It's not the most important to understand, but if you want to read and understand what it's doing, what we're doing is creating an express server. So there's that, right? And the bridge reader gets certain variables from my Bridgeport node when it gets spun up. Those are the port on which it should listen, the read credentials for a read-only user of the MongoDB database, the database name, and the bridge object itself. We can parse the bridge object. We set up our app with Express. We set our view engine and our views directory. We set up a public directory, which is that public folder. We're using express.json and cores for cross-origin resource sharing. Then we're doing an async function that basically connects the Mongo client to the database, serves the various routes. And you can see here, like this one is the res.render, the README, right? The README file, which is that .md basically is how that ends up working. Just kind of going over this at a high level. We've got a front end for viewing queries. That's what we're looking at here, is the query front end. I didn't write this, Unwriter wrote this. There's also one for the socket. That front end for the socket's right here. And there's a back end for the query, which is just some code that allows you to write bit queries essentially against the MongoDB database associated with the bridge. And the same with a socket for listening to live events and dealing with SSE server sent events. After all that's done, we listen on the port that was provided. That is the bridge reader. So we've gone through the necessary steps, save that documentation, which I'm going to do later, to write a bridge. Now, one other thing you can do just to get some more confidence, because I realized that we just wrote a bunch of code in process and in rollback that we haven't yet really gotten any confidence in, is you can write some tests. So I'm not going to write too many tests in this tutorial. I don't want to bore you with writing all of the tests necessary to bring all this code up to 100% test coverage. I think the stuff with rollback took quite a long time. I think that's the most important thing to understand is the concepts related to what I covered previously about that. What I will do is just demonstrate how you can write a test to get a bit of confidence in one of your things. So I recommend testing. I don't have tests on most of my things, but I recommend testing. Do as I say, not as I do. So I'm going to install save dev jest. So now we've got a test library installed, and we're going to go ahead and just mock out some very basic things. So process.js needs a test. So we're going to make a new file, process.test.js. Split this onto the right. So now we have the test on the right, implementation on the left, and I'll try not to pan around as much as possible while I'm doing this, but I may need to. I'm going to import, so const process. And I don't like to use the word process because it's actually a global in Node, so process. So there's that. Describe process, and I'm just going to write one test. So we need a mock state. State is require state mock state. I'm going to use a very basic code path here. It calls state.create with a new message. So I think this needs to be async for certain. Await process, and I think state actually is a wait a second. So we don't need to mock state. What we need to do is just fake state, because state is a function that takes in a database and a session, and it returns an object which has those four functions as properties of it. So we can just say, instead of that, we can say, instead of doing that, we can say fake state equals create and read, update, delete. Great. So read, update, and delete. So that's our fake state. That is useful for testing, because we can actually pass in process, say fake state, and the action that we want to take. So tx h mock txid. Input is an array where e, right? An array of objects where the first object has an object which has a property called a, which is a string, mock addr 1. We'll just say mock addr. Okay, so that's the input to our transaction, and we're going to say the first output out, and here's where we can do some. So S2, so S0, S1, so S2 needs to be the protocol namespace. S3 needs to be mock addr, addr. And S4 needs to be send MSG. S5 needs to be the message that we're sending. We'll just say mock hello. We'll just say hello. How about that? Message is hello. So S5 is the message, right? And this is what there's some mocked things that aren't really present, but that's fine. That's how tests work. You just put in what needs to be there, and you can maybe make it as close as you want to production. Do what you need to do to get confidence in your code. So we're calling our process function with this stuff here. And then what do we expect? I expect state, fake state, dot create to have been called with collection, messages, data, are we tracking sender ID? This is why we write tests, everybody. Wait. We were not tracking the sender ID, everybody. Yeah, we need to know the sender ID as user ID, which needs to be defined. In fact, I'm going to define user ID. See how much better your code gets when you write tests? So that can be defined up here because it's useful in both of the branches of that if statement. All right, I expect that when you send a message, the document contains the sender ID field. This is live. Sender ID is user ID. In fact, I'm just going to call that user ID because a message has a user ID, which is the user who sent the message. Maybe other people will do that differently, but we've got that. I'm expecting user ID to be mock ADDR. I'm expecting the message to be hello. And I'm expecting the ID to be mock TXID. All right. And running this test suite should actually produce a successful result. And actually, well, I'll just run it actually. I think I know of an error, but I'll see if it runs. I don't think there's a test script, for one. So our package JSON now has a couple more things in it. It's got jest for testing. And I also need to add a scripts object, which contains test. Am I going to be test watch? Jest watch. And just to be complete here, test jest. Only because it rhymes. Test watch, and we're going to see if our test suite passes. All right. We do see the log, right, plus the TXID, so it did call. We got error, and the error was error. Transaction has invalid protocol namespace. So there should be a test written somewhere that, you know, catches that. But I'm not trying to be that specific right now, so I'm going to put the correct protocol namespace in. And, you know, I'm doing part of this to save time. I'm not writing all the docs in this video. Now we can see our test passes because I put the correct protocol namespace in and because it correctly inserted the document into that database. So I'm sure I scared some people for a little bit where they were like, whoa, I don't know if this is going to work. I've just written all of this code. How the heck am I going to know that the database correctly inserted and interpreted my Bitcoin transaction in the way that I think it should, right? But just as with any other software you write, in fact, especially with this is a pure function, right? I mean, a state which can be mocked, an action, if you're familiar with like Redux, a pure function, very deterministic, based on nothing other than the state and the action. What will be the result? So you can mock state.read. You know, right now we have fake state, which jest.fn and whatever. But, read is this one here. Jest.fn and whatever. But you can return results, and you can say, well, if there was a result for the search query when we do name search or when we do search on line 38 of this file, right? You can return a result from state.read, and you can write tests that ensure your code works as expected. So, those are the two things I wanted to cover before I write my commit to this bridge. So I'm going to write a commit. I'm not going to finish the tests, and I'm not going to finish the documentation as of right now, so that I can show you the tutorial, so we can get on with actually, we've created this bridge. We've gone through the process of creating it. Now I'm going to assume you have a protocol. You wrote your protocol docs in that README.md in the bridge reader, so it's reader/README.md, right? This is where I kind of started to write my protocol docs. Now you've ascribed some meaning to some data in a Bitcoin transaction. You understand TXO format. You wrote a filter that filters out only the kinds of transactions that you want to be concerned with. You wrote a transformer including a rollback. And rollbacks probably take longer than the process function actually, because you want to make sure you're able to bring your database back to the previous state. You want to treat every Bitcoin transaction like a database migration. If you ever use like next and you go next, migrate : latest, and it brings it up, and then you say migrate : down, right? You bring your, anyways, I think I covered that before. So you write a transformer, including a process function that rolls the state of your state machine and your database forward based on the contents of a Bitcoin transaction as provided in TXO format. And then you write a rollback, which given the TXID, you don't get the complete transaction in rollback, you only get the TXID. Given the TXID of the transaction in the rollback, roll your database back to the state that it was at. You have to unprocess that transaction, which means that every current state must be a superset of previous state. It must contain a superset of the information as contained in previous state. So you've gone through all of that. Then you went and you made a bridge reader, which is a way of reading. And all you really had to do there is, do this .md file, reader/readme.md, which is the protocol documentation. That's where it gets hosted on the website. And you went in here and you changed your defaults to whatever data model you decided with. So your collection name and the things that are inside that collection. And now you've gone on the Bridgeport dashboard as well. You have gone through the process of having this bridge be created, and you signed off on it. And now what you have to do, after you installed that GitHub app as I ran you through, all that's left is you write a commit to the bridge. So we've got, I did git status. GST for me is git status. I'm going to write a commit. Say initial commit. And I'm going to push it up to the repository. Now you wait a couple seconds because this does take a bit of time, but come to your Bridgeport dashboard after you write your commit to master. Again, make sure in bridgeport.json that your repo token is correct. And you get that repo token when you first set up your bridge with the bridge ID and everything. When you generate the bridge ID and you sign and you get the repo token, make sure that's correct. If it is, after you've installed the GitHub app, if you've done all the things and you refresh the page, then you should see, had me nervous there for a second, you should see a deployment. And it looks like this deployment actually failed. So you can look at the deployment, you can see the deployment log, the commit hash, and now I'll read why this deployment did not succeed. Deployment of this bridge from this repository on branch master has failed, has started. Error with deployment. Command failed. Echo bridge equals whatever. So we're writing an echo command out here, and syntax error, unexpected quoted string. So my belief is that there may be a problem with the Bridgeport.json file based on looking at that error. And you're going to have to infer I probably need to escape something. Maybe it's that apostrophe. I don't know. So we're saying echo apostrophe, right? Bridge equals this whole thing. And there's an apostrophe. So no apostrophes in bridge names. And I don't like that. That's a bug in Bridgeport, obviously. I need to fix that. For now, I'm going to remove the apostrophe. And I bet when I write the commit, and by the way, I know perfectly well that there is going to be security issues with people doing string injection and bash and all that stuff. This is pre-alpha software intended to make a point that we can do this stuff and track state machines on Bitcoin. It is not intended to be robust or secure at this stage against a malicious attacker who's trying to mess with my infrastructure. I know that as well as anybody does. So I know that I'm running an echo command with user provided data. I'm running a bunch of stuff on my cloud architecture as well. But I just wrote a commit and I pushed it up, and I'm going to refresh the page. As time goes on, this will be hardened against security vulnerabilities. Now we can see the new deployment running. Still pending. This doesn't update with live sockets yet. You have to refresh. That will happen eventually. Eventually be able to see your logs on the dashboard for when people send requests to your bridge, when transactions come into your bridge. Eventually you'll be able to resync your bridge from the blockchain by using a button on the dashboard. Eventually you'll be able to edit the settings of your Bridgeport.json file and do all of that sort of thing. You'll be able to set a, you'll have to pay on a per transaction basis as the transactions go inside the bridge. That's the economic model. And I think there is demand for that. But at the moment, the focus is on getting people to understand how to build using this paradigm. So we're going to refresh again. Now we're going to see, still pending. This does take a bit, but now we can see that it's deploying the bridge reader. Bridge reader gets deployed first, and then the bridge transformer gets deployed, and then we see a success. So if I go back to another bridge, if we look at the Convo user profiles protocol bridge, we can see there's been 3 commits. Use Bridgeport 2.0, because there was a Bridgeport 1.0. It was just closed source and nobody could use it except for me. See this deploy, it succeeded. Bridge transformer deployed. finished processing. And then there's this one, and there's this one, right? So use live events and then add links. So those are just commits in that repo that have happened since the bridge was installed, or since the bridge was created. So now we're going to find wherever this one is. We're going to find ties postboard bridge. And we can see that we deployed the bridge reader by now. And we're starting the deployment of the bridge transformer. But we got work to do, don't we? We got a UI to build. We built a bridge. But no. Building a bridge is not good enough. We need to build a UI. We need to make this work. So one repo down. I'm going to collapse this repo. Ties postboard bridge now exists. Now, here's where our application's probably going to diverge a little bit. What you're doing, you might have built a different bridge. You might have decided on a different format for storing things. You might have decided to parse Bitcoin in a different way, filter Bitcoin in a different way. You might have, you might have done a lot of different things than I have. But because I built my bridge the way I did, with the data pulled into it the way that I pulled it in, what I'm going to do is go to my UI and plug in my bridge.